Okay, so in this video, we are going to look at the 41st question in Project Euler. So let's see this question here. We don't have the hangout last week because I'm busy. So now for this week, I will resume the hangout. So anyway, just see the question. Okay, so the question is this: pan-digital prime. We shall say that an n-digit number is an pendigital if it makes use of all the digits ones to n exactly once. For example, 2143 is a 4-digit pentagital and is also a prime. So what is the largest n-digit pentagital prime that exists? So for this question, um, the description is pretty self-explanatory. So if your target is to find the largest n pentagital prime that exists. So since the question wants largest pentagital prime, so we should start with the 9 digit first and 8 digit and so on. Once we found the solution and that it is, so we can call this is a greedy solution. So if we find the 9 has such solution, so we will take the solution of 9 and 8. If 9 doesn't have 8, then we take 8. So let's see the solution here. So my solution is basically the using DFS. I search through all the possibilities from 9, 8, 7, 6 numbers. So let's start with the number of 9 first. So if we say that the pan-digital prime, we should have 9 digits if we want to find 9-digit pan-digital prime. Because pan-digital is a number that makes use of all digits as exactly 1. If you have n equals to 9, then you should have 9 digits in it. If you have n equals to 8, then you should have 8 digits in that number, and that number must be prime for this question. So this is an example of n digits prime. This where n equals to 8. So let's say for 9, then you have something like this. Okay, so this is 9. Our vision is to find the largest pentagonal prime from it. Okay, so first we start with constructing the possible solutions. First we start with the depth equals to 9, so we start with the first solution, that the maximum solution, because we want the maximum value, and depth is more than 1 and max is equal to 0. If we found max, then the loop would not continue. Then that minus minus, which means that if we have 9, we check for 9. If 9 digits does not contain pan-digital primes, then we will proceed with 8 digits, and then 7 digit, 6 digit, and so on. Next, we start with the depth. The depth is here means the number of solutions that we have. Perhaps I explain it another way. Uh, for depth equals to 9, which means we have 9 numbers, so we should have the starting number of 9 or 8 or 7 or 6 or 5. So it could be 1, 2, 3, 4, 5, 6, 7, 8. So we start with this. However, to get the maximum value first, I shall start with the 9 first. So, so the programs run something like this. It should be the last. So I will start searching from here first. So next, this flag is to indicate which digit is used. If it is used, then it should be true. So here, I mark the flag as true for each instance. Let's say if I have 9, I start with 9, then the flag for 9 should be like this. The 9 should be true for flag. Or for 2, the flag should be 2 because 2 has already been used. So next we start with the depth search. However, I will not search when the number construction is being done. Instead, I search when the number is completely done. Let's say if we search for n equals to 9, then we should only check the number, whether the number is a prime number when the number is 9 digits long. So if current that, which means that we have reached the maximum number of digits that we want to find. So if so, then we will get the prime. We will check whether the number is a prime or not. If yes, then this is the max value. So the loop here should stop. Else, if max equal to 0, which means that we have yet to find the max value. So next, we will add the value. We will add the number because the number here has not been constructed completely. Perhaps in this stage, for the first instance, so because in here, this is not an pen digital number, so we will not check it. We will only check it when it reaches this stage. So at this stage, on the next instance, you can times a 10, then add the number behind it. So how do I construct this number? The code is here. So I start with the max step. Then I equals to more than 0 because we don't want to have 0 included in it. So basically, I'm constructing the number that is bigger. So the number that we have constructed could consist of something like this. So I'm basically constructing out the possibilities. This is the maximum depth, which means that the number that we have to add, because if n equals to 9, then this one should be 9. So we'll start from the larger number first. If the number is yet to um, contains in the digits that we want to construct, then we can add it. Next, we'll proceed with this because we need to construct the number until it is n digit pen digital. And next, to um, keep the performance up, we set it back to false. So from this recursion, we'll get in the end we'll get everything true. But when coming out, we mark it as false. So this will be false, this will be false, and this will be false, and it will continue to the recursion continue to do that for all of the possibilities. So by using this method, I don't have to create an array for each instance. So this can helps to improve the performance by a lot. So next, this is the prime number checking function. So this is pretty simple. You can do it yourself. So since we have talked about it so many times in our previous video, so I'll skip this. So let's give this program a try. So this is the solution that we have found. So let's compare it with the answer here. So yes, this is the solution, which is same with the official answer given by Project Euler. So So yeah, this is the solution that I have done. So you could have come up with your faster solution, then that's a welcome. So that's it about this question. Pretty simple. I just use a DFS to construct the all of the possible combinations, and in the end we get the maximum value. So once we get the maximum value, we stop the searching because the question wants the maximum value. So when constructing a number, we should start with constructing the larger number first instead of the smallest number, so that we can stop the operation immediately after we have get the Panticial prime. So if you construct it from small to big numbers, then the speed will not be that fast because you have to search through more possibilities compared to if you start with uh, big bigger number first. So that's it about this question. So if you have any problem, you can email us or contact us. Yeah. So please remember to subscribe to us for more programming tutorial. So that is it about this question. Okay. So goodbye.